Hard-coded credentials can be trouble, but not as much trouble as a vulnerable DevOps environment. If you want protection without the hassle of security slowing you down, CyberArk, the #1 provider in privileged access security, has the solution for you. With CyberArk Conjur, developers can easily secure secrets across any DevOps toolchain or platform, whether your application runs in the cloud or on premises. Eliminate the headaches of managing secrets and try Conjur open source for free with no strings attached. Visit conjur.org/ASW to get started today. Do you need a web application security solution that can improve your detection rate and enable easier remediation? Acunetics has a fully automated solution that can detect and report over 4,500 web vulnerabilities. Fast and scalable, it can scan thousands of pages without interruption, including HTML5, JavaScript, and single-page applications. Acunetics provides accuracy with the lowest false positives by combining black box and white box testing. For more information, visit acunetics.com/securityweekly.
Welcome back, everyone, to Application Security News for the week of December 2nd. Before we jump in, one quick announcement. If you are interested in quality over quantity and having meaningful conversations instead of just a badge scan, join us April 1st to the 3rd at Disney's Contemporary Resort for InfoSec World 2019, where you can connect and network with like-minded individuals in search of actionable information. Use the registration code OS19-SECWEEK for 15% off the main conference or World Pass, there. With that, diving right into this, I thought it was pretty cool, Paul, that some researchers at a couple of universities recently took the AFL Fuzzer and built upon it a little bit to actually make faster fuzzing of basically binaries and reverse engineering things to find more bugs. This was pretty neat.
Yeah, it's interesting, Keith. I covered in Paul's Security Weekly, I covered some new fuzzing technique thing. I'm wondering, actually kind of hoping it is the same story because I really didn't do it justice on Paul's Security Weekly.
Yeah, so in this case, what it was is it was a group of researchers from several different universities teamed up to go and look at the American Fuzzy LOP, or Fuzzy, where is it here? AFL Smart, and I was just go reading through my notes. Yes, so it's a American Fuzzy.
My article was on smart gray box fuzzing.
Yeah, this is the same thing.
Okay, it's the same thing. Yeah, I see now. American Fuzzy LOP.
Yep. So I was like, the LOP didn't sound right for some reason. I was like, wait a minute. No, and I was thinking of a researcher who goes by Fuzzy Nop.
It's different. Yes.
Yeah. So he used to work for Salesforce, that whole thing. Anyway, so this is American Fuzzy LOP to look at. Well, what they did is they took this toolkit and actually built upon it to be a little bit more intelligent. So these were researchers from, let's see here, where were the universities in this article? It had them from, all right, here we go. National University of Singapore, Monash University of Australia, and University Polytechnica of Bucharest were kind of the joint set of researchers, which, I mean, talk about being all over the map, right? Like that's 3 different universities from pretty distinct regions of the world all working together to come up with this nice white paper on actual, increased and enhanced fuzzing. In fact, when they were running it in comparison to AFL from like a benchmark testing, they found on average twice as many bugs as the original American Fuzzy LOP over the same 24-hour period of time, and actually have something like 42 zero-day vulnerabilities, banking 17 CVEs listed on open source software libraries that they've run this against. I mean, talk about badass, right? Like you found 42 zero-day vulnerabilities off of this new tool that you've built in open source repos. That's pretty awesome.
Yeah, in the article that I covered, it said that they changed the fuzzing method to do what they call innovative mutation operators, which work on a virtual file structure rather than at a bit level. So the file, what I kind of gleaned from that, and I didn't dig into in any detail, is what they say in the article is their method helps ensure that the file types are valid, but are still morphing to complete the fuzzing operation, whereas the other types of fuzzing have a higher degree of the file that you're created to fuzz the application wouldn't be valid. That's where it seemed to me like they got more success with their method.
So the way that they actually talk about it is most fuzzing tools basically flip bits inside of the application itself, slowly looking for input fields effectively, right? They're
Yep.
just looking for opportunities to provide input to the application. And so because of it's the flip one bit, flip a second bit, flip one bit, flip another second bit,
Yep.
that's a slow process. Whereas in this case, they actually kind of look at the application much more holistically, right? So
Mm-hmm.
rather than just fuzzing for bit flips and saying, okay, do we have an input field here? No, flip the next bit, and on and on and on. What they would do is they would go ahead and derive structural representation of the seed file called as you said, called a virtual structure, and then using smart mutation operators to modify the actual virtual file structure itself. In addition to the file's bit sequence, they would actually be able to search for the generation of new input fields. So it sounds like they're doing a little bit of both, right? They're doing the original bit flipping sequencing and also this virtualized structure bit flipping. Now, I imagine if you take that and you scale it up, right? So you
Mm-hmm.
now have the virtualization and you create 10 virtualizations instead of just one additional virtualization, you'd probably be able to go even faster, right?
Yes,
So
it sounds like
it,
they're focusing on what is valid rather than just fuzzing everything, which kind of reminds me of parameter-based fuzzing. If you got a web
yep.
app and it's got three different parameters, and you set the first one to one option, then you get to the other two values to two different options, and then all the permeations, and they run through every single one, and then your web app scan would take 3 years to complete because if there's 10 parameters, you got to go every possible combination, similar to brute forcing. But they're adding in some intelligence to that, which is I think how we also overcame the parameter based fuzzing as well.
Yeah, yeah. And in this case, they're looking at it to explore those mutations as valid, right? So it's okay if we bit flip all these things and we only find valid mutations in the following places. Make sure we test those structurally. And I imagine also the virtualization aspect to this as well. You can run through virtualized files a lot faster than you could probably run through them natively, just
Mm,
because of the way that you're actually flipping the bits in memory versus kind of that virtualization.
interesting.
So that is probably a little bit about why they got all of this so successfully completed. I'd be interested to see if they're now able to scale it, right? So for some sort of AWS compute, cost, they could actually get 3 times as many, mutations in half the time, and therefore increase the actual fuzzing abilities of this. That would be
Oh,
cool to see
so
as well.
it's also interesting from the article building. It says building the article that I linked to originally from last Thursday was they built upon the AFL Fuzzer originally developed by Michael Zaleski. Zaleski. Do you know what he developed
Yeah.
originally? I can't even say his name right, but he's the original developer of P0F.
Oh, really? No kidding. Oh, that's
I'm like,
pretty
his
awesome.
name looks
Um,
familiar.
I'm trying to go back and also look at this as well now. Anyhow, I thought this was a cool article.
I
This
did
is
too.
story
Yes.
if you build it, they will come. There is the research paper that is now publicly available for this as well. So if you're into the whole reverse engineering bit flipping fuzzing
Mm-hmm.
scene, definitely go check it out because I think that this is going to be pretty awesome for researchers in general to go and check out themselves as well. Um, Another cool story that I thought was pretty interesting was how malware and rogue users can spy on some apps' HTTPS crypto, which is kind of creepy considering that you shouldn't be able to spy on people's TLS connections. Um, but this one is also another paper that was recently published on last Friday called "The 9 Lives of Bleikenbacher's Cat: or New Cache Attacks on TLS Implementations," with several co-authors. I'm not going to give their names because they're probably way too hard for me to pronounce. But
Mm-hmm.
again, story number 2 under "If You Build It, They Will Come." It was also in the register where we're getting the source for this. What they ended up doing is they actually combined a couple of different techniques to make this possible. So they were looking at padding oracle attacks. So basically fuzzing with dummy data to try and get ciphertext back out, as well as, of course, looking at design flaws, such as what you see in Spectre and Meltdown, to be able to do cache-based side channels to get basically ways through the defenses that normally prevent this sort of thing from taking place. And so what they ended up doing is they're using what's called flush and reload, in which the attackers will flush and reload parts of the CPU cache while the victim is accessing the same area of cached memory. And they can basically determine whether or not there's any data in there because of the speed at which they're actually able to flush and reload that cache. If there's nothing in there, it should reload faster. than if there's some actual data there to grab. They combine that with the browser exploitation or browser exploit against SSL TLS, also known as the Beast vulnerability,
Mm-hmm.
to basically combine the two and then start to steal encrypted data right out of the cache, which I thought was cool because, first of all, it works on a lot of things, kind of scarily enough, and it allows them to get access to data. Now, I should say some key points here. You either have to have local access to the box, or you have to have malware running on the box for this to actually be possible. And it mostly works because of the fact that there's still RSA key encryption key ciphers that are allowed for downgrades in certain cases. And so because of that still being in existence as part of like a cipher suite that a lot of different services offer, because they're TLS 1.2, not TLS 1.3, you can actually make use of this attack in the wild if you drop some malware on a person's system, which is really bad.
You know, I just found it interesting that, and I'm sure a lot of other people already knew this. Like Google hires, like I swear there's a team at Google that specifically goes out and finds like people who did research 20 plus years ago and were pioneers in their field, and then hires them today. So, who was the one
Project Zero? I mean, I know that they're hiring people today too, but
yeah,
that's
but
pretty much what they do is
right.
They go and hack all this
Daniel Bleikenbacher, who's mentioned in this article, is finding some of the 20 years ago, finding some flaws in the RSA algorithm. He now works for Google. Last week's interview was with Vitsa Venema and Dan Farmer, and Vitsa works for Google. He's one of the original co-authors of Satan. Vitsa also wrote TCP wrappers and postfix, for some history there. And if you dig it, right, Go programming language, Ken Thompson, right, one of the original Unix people, works for Google and worked on the Go programming language. So I thought that was, I don't know. I just put all those pieces together in my head. I'm late to the party.
So it's almost like they're playing Pokemon with really profound developers.
Right.
Got to catch them all.
Yeah.
So with this, it's funny because the whole I just love how it's the 9 lives of Bleikenbacher's cat. Like how they basically took this old research and then just kept on kind of spinning it a little bit more. To figure out how they could take everything that's old and make it new again.
Yes.
And the combination of attacks too. So the things that they tested it on, by the way, where it worked: OpenSSL, Amazon S2N, Embed TLS, Apple Core TLS, Mozilla NSS, Wolf SSL, New TLS, and then it did not work for Bare SSL and Boring SSL. But the attack, basically, again, if you drop malware on the system, and for those that work in the enterprise, that happens. Like if you drop that on a developer box somewhere and suddenly you were pulling out, I don't know, key material for the production instances, good luck, have a nice life, because suddenly you just lost maybe SSH keys, maybe you've lost, I don't know, the commit keys to GitHub, for example. There are any number of things as encryption of key material for the connections you're making to important sites or important processes that are just not great to have leak. And this is yet again another opportunity for data to leak out of your enterprise environment that are, in this case, encryption keys. I don't know. This one was kind of scary to me, Paul.
I think scary is also your next story too, which confirms many of my fears of deprecation.
Oh, yeah. So this is actually tied also to story number 3 under Bugs, Breaches, and More, which is basically the process of exploiting developer infrastructure and how easy it actually is. So for those that are late to the game on the story, there was a package called Event Stream or Event-Stream that actually was handed over to a separate developer other than the original for continued maintenance. And that other developer actually ended up putting Bitcoin stealing malware wrapped into the version, I think it was like one of the version 3.x's, did a version bump. So anybody that was auto updating would actually get that potential malware, and then did like another release where they actually removed the code thereafter. So basically everyone in like the 3.x branch had malware in it, and everyone that was in the 4.x did not. But it had something like 1 million or 2 million downloads a week. And
millions of downloads a week, right?
Yeah, and it was up there for I think 3 months. So think about this. Let's call it, I don't know, 5 million a month, right? Just basically, maybe you have 1 million and 2 million somewhere in between every week, right? 5 million a month for 3 months. There's 15 million potential downloads. That's a pretty hefty market considering that it's largely tied to developers that are picking this up. It's not just random mom and pops off the street. It's actual people writing code that now have this in their environment and probably are a higher likelihood of having some sort of cryptocurrency on their system, maybe compared to the general, broader populace. So yeah, like this could have been a lot worse. This could have been backdoors. This could have been, I don't know, writing malicious code into applications in some way that exploited the
Well,
general populace and not
yeah,
just the developers on their end box.
it's interesting. The author of this article that we linked to in the show notes says, let's count all the things that went wrong. It talks about all the potential pitfalls of open source software, and many of them anyway. And I think in his list, really, it comes down to, I mean, it's not the only thing. I think the most important thing in these types of situations is number 6 in his list. The maintainer gave full control to an unknown entity just because they asked for it. I think
Yep.
a lot of these attacks can be solved with education and just making sure that you're vetting who you give access to and
Right.
controlling access. But the thing is, that person that they gave access to may not have been the malicious person. Maybe that's someone that it was victim of a password spraying attack or some kind of phish or something like that, right? So you're going after the other people in the project, not the actual project maintainer.
Right.
I'm sure there's multiple scenarios that play out to lead to this type of situation. But I think as a maintainer of an open source project, you now have to be very cognizant of who you're giving access to and verify them to a certain degree. And of course, that's hard. But I think one thing that can help this problem in a big way.
And it's interesting, Paul, since you mentioned that under story number 3 for bugs, breaches, and more, the first bullet that's just below the original article, the original statement from the maintainer,
Mm.
this was a really kind of an interesting read because the maintainer responded to, the same sort of comments, right? The same sort of like, why did you give it to this random person? Like,
Hmm.
what were you thinking? All these other things. And the way that they equate the situation is, and if you actually go back and look at Dominic's kind of commit history over the last several years, back to like 2012 or so, they've got like 4,000 plus commits every year, which is incredible. First of all, I mean, the most I've
Hmm.
ever had is maybe 2,700 commits in a year. And then, secondly, though, they point out that it wasn't fun for them anymore, so they stopped maintaining the package. And
Hmm.
at this point, they actually compare it to when they were a dishwasher at a restaurant and very young, earning an income, and they got promoted to chef, but it was only 50 cents more of a pay raise, but a lot more responsibility,
Yep.
and it wasn't worth it. And that's what writing open source software is, like a
Yeah.
million times over. So it was interesting to read kind of the feedback because they said, yeah, like this happened, but guess what? This isn't the last time that I'm going to walk away from,
Hmm.
something that I've built or all of these other things that I'm going to build. And it's not going to be the same case for, by the way, almost everything else out there either. So there's really only 2 solutions. And I think that these solutions are interesting in their own way. The first is pay the maintainers
Right.
because, by the way, you can only depend on the module if it's definitely maintained, and they're not interested in maintaining it unless maybe they get paid for it. The second one, which is also a valid point, is if you depend on it, maybe you should take part in maintaining it yourself.
Hmm.
Uh, so that's, and I can see the second one actually happen a lot more often where people will fork a project that is no longer maintained, and they kind of become the new main project over time. So that is something that tends to happen every now and then. I know that it happened with Sublister for a little while as a kind of a bug bounty hunting tool that I tend to use, and it's happened with other projects that I know of as well. And so it's, I don't know, it's a catch 22, right? You're kind of damned if you do because you've made this project that now is really popular, and you're damned if you don't because it's no longer maintained. It'll have vulnerabilities of different kinds. But maybe this is also an opportunity for something that we talked about. I think it was, I don't know, several months ago at this point, Paul, which was Google is paying people for patching or fixing security vulnerabilities in open source projects if the maintainer doesn't. And maybe that's the model we need to go with, right? Like, get a really popular repository of some kind or a project of some kind, and if you stop maintaining it, somebody else pushes in or submits bug fixes for security vulnerabilities. Everybody wins.
Mm.
So I don't know. It was interesting to look at because on the one hand, yeah, like the ease at which you could basically exploit the developers because they are pulling down all these packages to their local system, huge and really, really dangerous, especially considering I think it was last week we talked about how many businesses are actually encouraging their people to use open source software. It was the DigitalOcean survey that they did.
Right.
So, I mean, combine the two, and I think 2019 is going to be a really interesting year, Paul. We're going to have a lot of news to talk about.
We're going to continue to talking about this because there's going to be new information coming to light, I think, all the time about this particular problem, which it's always been there, and I just think now it just exacerbated to the point where it's just becoming very common, you know.
Yeah. I mean, it's almost scary how common it's become. I think that, you know, over the course of this year, if we were to go back and reflect, and maybe we'll do this, say on like, I don't know, the last episode of the year, we'll go back and do a reflection on, okay,
no, people hate that.
Over the year?
Just an FYI, people hate that.
Well, maybe not then. Maybe I will anyway. I'll just post it to Twitter. But it is one of those things that we have talked about a number of bugs just like this throughout the entire year, whether it was, you know, people losing access, people not having two-factor authentication, you know, etc. Right? People typo squatting. And this is just going to be a bigger problem. Like as we go into 2019, it's just going to get even bigger.
Yep.
So speaking of, you know, fun open source projects that are out there under the learning and tools section, which we haven't been talking about as much lately, so I do apologize to our listeners for that. There are a couple of really cool tools that I did highlight in this week's episode. So number one under learning and tools is XSS Fuzzer, which looks really awesome. It's under Kitploit or kitploit.com. And it actually builds new XSS vectors for any browser. And then it tests them with get and post parameters, which, by the way, you'd be interested to find how many XSSs actually come out of the fact that you're doing it as a get request. They patch the get request and
they don't patch the post.
It still shows up.
Yep.
It also does some bypassing for you as well. So XSS auditors as well as web application firewalls, you know, the only protection that you need. So, yeah, it's one of those things that as a tool, I thought that this would be a great way for folks to go in and test their own web applications, especially if, you know, you're worried about XSS, input validation, output encoding, and all that good stuff. So definitely check that one out. Paul, did you check out
what is this kit? What is this Kitploit? That sounds like a cool website.
Yeah, it's hacker tools. So I've actually linked a number of things in Kitploit. So some of these are open source projects. Some of these are like released as tools to the community that, you know, maybe they're released at a website, as this one is at xssfuzzer.com. Maybe they're released at like a conference. And so it kind of keeps track of all of these.
I like it.
And I've had a number of different learnings and tools, things that show up on here as like, hey, that's really cool, as is XSS Fuzzer. So definitely check that one out. Nice. But Paul, did you see the announcement for Firecracker that Amazon announced last week at reInvent?
I saw it because you added it to the story, so I want to learn more about it.
So this was interesting because they're kind of going all in on serverless with Firecracker. So basically what they say in the article, which is story number 2 under learning and tools, is existing virtualization technologies weren't developed for optimized event-driven, or in this case, short-lived environments or workloads. So what they did is they took an open source virtual machine monitor called Firecracker, which uses the Linux kernel-based virtual machine, or KVM, to build a lightweight, exceedingly secure and minimalized micro virtual machine, or micro VM. For specifically running serverless architecture. So now, if you wanted to go ahead and have it's almost like the idea of a container, but even lighter than a container, right? It's so simple and basic for use that it's intended to just run functions, and that's it. But written in Rust, which I thought was kind of interesting. They actually say about a year ago, they decided to write it in Rust because it guarantees thread and memory safety to prevent buffer overflows or other types of memory errors, which, you know, forward thinking, that's definitely still an issue today, which I thought was kind of cool. Although I can only imagine the pain of writing, you know, in Rust, because it's like writing code in a straitjacket, for lack of a better term. I don't know. Maybe people are into that sort of thing. Uh, but with that being said, because of the overhead for these things being less than 5 megabytes per micro VM on memory, they could run thousands of them on their infrastructure. Or if you had, on-premise infrastructure that you wanted to load this into and run your own kind of serverless architecture internally, you could for like next to nothing. So that was really cool as well. I don't know, Paul, did you read any more into this as well? They actually do talk about Fargate as well as some of the other tooling that they have for the Amazon infrastructure that's available today. And they do talk about how this is intended to be run beyond or faster than some of the other technologies.
I didn't. My question was, you answered it, was could you run your own serverless environment using this? And it sounds like the answer is yes. And then I saw the next website about the state of JavaScript, and I was really distracted because it's got lots of cool clicky blinky things.
We can definitely jump to that. One last thing I did want to say about this is it runs on Intel processors today. Support for AMD and ARM are coming in 2019, which I thought was also pretty cool that they're kind of going that route as well. But yeah, the intention is, okay, you want to be able to run this locally as a developer, go ahead, you can. It's really lightweight. Also, you can do it inside of Docker container orchestration frameworks such as Kubernetes that will use Firecracker as well, and it's open source, so you can contribute to it. Hopefully, they don't pass the keys over to anybody that wants to put Bitcoin mining stuff in your Firecracker, so that you could stick it in your Firecracker and smoke it, as it were. But yes, the state of JavaScript. So this one was a really cool website in general. So it's kind of like a general survey / review of the state of JavaScript, and of course, it's written like all in JavaScript. So as you mouse over things, it has kind of interesting reactions to your mouse clicks and your mouse overs.
It's crazy. It is like the coolest website of the year. One of the coolest ones. Yeah.
The demographics one is probably one of my favorites. Like you go to the demographics and then you just kind of mouse over the different areas, and it tells you, participation by country. It tells you salary information.
It's so cool.
Years of experience, company size, gender breakdown. By the way, there's like a lot of, I'm not going to go there, a lot of men that responded to this, something like 18,000 men versus about 930 women. Non-binary was 142, and then other was 62. So there was a lot of men that responded to this. Not terribly surprising, I guess, but it kind of shows you the discrepancies of balance within the different gender identities inside of the space. The other cool things, though, is connections, Paul. I don't know if you checked out this.
Oh, yeah, I was playing around with this, yes.
Yeah, so Electron has something like 31,198 different connections into different other frameworks, such as Jasmine, Mocha, Storybook.
I didn't actually know what the graph meant. I was just like, that's really cool. And then now I understand.
No, you like mouse over these things and it tells you where those connections are.
That is the coolest graph ever. Oh my God, that's so awesome.
ES6 is probably my favorite one if you actually highlight over them. ES6 has a lot of really cool connections and like the strength of the connection too.
Yeah. It's so the thickness of the, wow.
Yeah.
That's so cool.
Yeah. This one blew my mind. When you go to JavaScript flavors, it kind of has some nice charts in there as well. And then you can actually go even deeper into like ES6, for example.
And like you can mouse over everything and it gives you, it's amazing.
Yeah. This really is cool probably my favorite website all year. I would agree with you here. So
I saw a similar one when I was researching my hip hop talk. That it was almost as cool as that one, and those were the two that stuck out in my mind as like the coolest sites that I've seen all year.
Right. One of my favorite things, just the last thing that I'll opine on this topic, is if you actually go to other tools, and it does cover the popularity of other languages as well. So if you're looking to become multilingual in the development space, it tells you kind of an idea of where a lot of other people are. So probably where a lot of support actually is from like documentation / questions on it on Stack Overflow. By the way, Paul, one thing I do want to point out though is text editors. The most used text editor by like 3 times over, VS Code.
I was going to say, well, if you're doing JavaScript, it's VS Code.
Yeah, it's pretty awesome. So I'm just loved this site in general. I hope they do this again for 2019 because I'm curious to see where the trends go, but also I just want to see another website like this. It's just really cool. So, um,
Sorry, I had a piece of tobacco stuck in my teeth, and they never mind. It cut it. Thanks.
I kind of figured that would be the case. So, with that, one last thing I just wanted to point out, of course, is our commit strip comic of the week. If it's not broken, I think for our listeners out there, especially those that are on call, might appreciate this one. So, with that, thank you everyone for joining us for another week of Application Security Weekly. Remember to git commit and stay classy.